Hello everyone and welcome to another BlenderMadeEasy tutorial. Today we'll be creating this satisfying animation of fluid particles inside a sphere. I'll be going through the process of learning how to add fluid inside a collision object, which is a little bit more complicated than you might think. Then we're going to create a fancy material. Let's go ahead and get started by deleting the default cube, and then we'll press Shift A and add in a new UV sphere. We'll open up this panel on the bottom here and we'll subdivide this a little bit more. Let's go up to 64 segments and 32 rings. Then you can press N and we'll scale it up to around a value of about 2.8, somewhere around here. It doesn't need to be exact, but roughly around there. Then we'll drag it up so it's sitting on the grid floor. We can also right click and shade it smooth. At this point we can add in the flow object, so I'll add in a new UV sphere, drag it up and then place it in the middle of our other sphere, something like that. Now let's add in the domain object. I'll add in a new cube, we'll drag it up and scale it up, and it can be about the size of the other objects, right around there. You don't really need to create it super big, just something like that. Now to get the fluid to actually appear inside this other UV sphere, there are a couple of things that we need to do. When you try to add fluid inside a collision object, a couple of things might happen. The fluid will not simulate at all, or it will just go right through the collision object, or it will kind of work, but the fluid will still go through the collision. So what we need to do is set up this collision a little bit. First off, we're going to select it, and the first thing that we need to do is invert the normals. If we go into edit mode, and I'll come over to this menu and turn on the normals so you can see the direction, they are pointed in the outward direction. They're going this way. What we need is for the normals to be on the inside. This is going to tell Blender that this is an empty object, because right now Blender thinks that this object is completely full. We need to invert them so it's empty. To do this, we're going to press Shift N and then click on Inside. Now the normals are pointed to the inside of the mesh, and that is what we want. The other thing that we need to do is add in a hole on the top of here. If we don't do this, the fluid will not simulate. So we need to go into edit mode, and then we'll just delete this single vertex on the top here. Press X and delete it. Just like that. So we have a little hole on the top of our UV sphere. Let's test this out by selecting the domain, jumping over to the domain settings, clicking on fluid, and setting the type over to domain. We'll set the domain type over to liquid, and then we'll change the rest of these settings later. Let's set up the flow object and the collision. We'll do the collision first. Select fluid, set the type over to effector. We need to make sure isPlanar is enabled. Since this object is now completely flat since we cut a hole in it, we need to make sure that is enabled. Let's select our flow object, click on fluid, and set the type over to flow. We're going to change the flow type over to liquid, and then we're going to leave it on geometry. If we select our domain now and then refresh it right here, just by changing the setting, we'll restart the animation and play it, and you can see it's still not working. The reason for this is because the resolution is too small for this hole on the top here. What we would need to do is cut more of this mesh off, then a value of 32 should work. But if we bring this up, let's go with 96. Once we do this, now you can actually see the fluid inside. Since this is a higher resolution, we don't need as big of a gap in the collision object, so 96 will work. The other thing that we're going to do though is add in another object. Since we're going to have the particles kind of fly around in this collision object, some of the particles might exit out of the gap on the top here. To prevent this, let's add in an outflow object. Let's select this object here, we'll press Shift D, and then scale it out just slightly so it's bigger than the collision. Let's fix this hole on the top here by going into edit mode. We will select there, and then we'll just hit E to extrude, right click, S, and then type 0 to scale it in, enter, and then we'll remove the doubles by pressing M and then clicking on by distance. So now the sphere is back to its original state with it completely full. We're going to change the type over here over to flow, and then for the flow type, choose liquid, and then for the flow behavior, we're going to choose outflow. This means whenever fluid hits this outflow, it's going to be deleted. And the normals are already pointed in the right direction. We need to make sure they're pointing inwards, and they already are since we duplicated this collision. If you have some particles that fly out of the collision and end up on the ground over here, you can open up the flow source over on the outflow settings and bring the emission value up. Let's try a value of 0.2. With that done, I might scale it out a little bit more. You want to be careful with this value because if you go higher, it might actually go inside the collision. The bounding box of the surface emission might go inside and it might delete the fluid. So probably around this scale with a value of 0.2 will work perfectly fine. What we can do next is select the domain, and we'll set up a couple of settings here. I'm going to turn off all of the border collisions down here just in case some of the fluid gets out of the collision. It won't appear in the domain. Also, I'm going to switch this back down to 32 so we can speed up our workflow. I'll turn all of these off just like this. The other thing that we're going to do is change a couple of settings down here. The sampling option allows you to have more particles. It's going to sample the fluid simulation multiple times, so it's going to add in more particles. Let's go up to a value of 5 so we get a lot of particles in the scene. The other option is the narrow bandwidth, which we've discussed a lot on this channel. We're going to go up to a value of 15. Also, turn on fractional obstacles. Fractional obstacles allows the fluid to go smoothly over the collision. This means that it's going to fly around this collision object very smoothly and it's going to look really good. So make sure that is enabled. And finally, before we bake this in, let's add in a force field to actually mess around with the fluid. We're going to press Shift A, add in a force field, and then select turbulence. We'll place it over here on the top. We're going to set the strength of this turbulence to 15, and then the flow down here to a value of 0.2. Now let's go back over to our domain. If we were to bake this in right now, the turbulence force field would be at 100% strength the entire animation, which is going to make our fluid way too chaotic. What we're going to do is turn on the turbulence force field at a certain point in the timeline and then turn it off completely. This is going to give some random burst of energy to the fluid and it's going to look really nice. We can do this by going over to the field weight section. Here is where we can take certain force fields and set the strength of them. So we're going to be animating this turbulence setting right here. So what I want is for the simulation to run its course at frame 80. We're going to make sure this is set to 0, the turbulence setting. We're going to set that to 0 and then hit I while hovering over it to add in a keyframe. The turbulence force field is then going to turn on over 20 frames. So go over to frame 100, turn this all the way to 1 and then add in another keyframe. So it's going to turn on slowly over 20 frames. Then at frame 101, we're going to turn it off and add in another keyframe. Then the fluid should go back to its original position. We're then going to do this multiple times. Let's select both of these keyframes, Shift D them, and then move them over here. We're going to move them to frame 180. So over 80 frames, it's going to be turned off. Then at 180, it's going to turn back on, and then it's going to turn off after 201. And this is going to give us a really cool movement with the fluid. The other thing that we need to do with this simulation is we need to animate the particle radius. Because at the moment, with it set to 1 and with the turbulence force field turned on, the fluid is going to kind of build and gain volume as the turbulence is working, and it's going to look like the whole thing is getting filled up. To counteract this and to make sure the fluid does not gain volume, we're going to turn down the radius as the simulation plays. So what I'll do is I'll go over to frame 80 right here, and then I'm going to click that little button on the side to add in a keyframe to the particle radius. We're then going to skip to frame 100 and bring this down to a value of 0.85 and enter. We'll add in another keyframe. You might need to play around with this value. A lot of the testing I did, I changed the setting to like 0.7 or 0.9, and I found that this value works pretty well for this scene. We'll then skip over to frame 180, add in another keyframe. Then we'll skip to frame 200, and since the turbulence is now done, we're going to bring this down. Let's go with a value of 0.7 and enter, then add in another keyframe. So this is how it's going to work. It's going to remain at a value of 1 all the way to frame 80. Then as the turbulence is working, we're going to bring it down to a value of 0.85, which should decrease the radius, making it look like it hasn't gained volume. That's going to remain the same all the way to frame 180. And then over 80 to 200, it's going to decrease even more, and then the fluid should look pretty normal after 200. And finally, before we bake it in, let's select the turbulence force field, and we're also going to change the position of this on the different points, because if it's in the same spot, the same turbulence is going to be applied on frame 180 as well. So what I'll do is right around here, like 150, just somewhere between the first turbulence and the second one, we're going to add in a keyframe to its location. Right here, press I, select the location, go to the next frame, and then let's just move it like over here, and then maybe over here. Press I and add in a location keyframe again. So at this point, it's just going to move over there, and it's going to give us a different variation in the turbulence. So with that done, we are ready to bake it in. Let's select our collision object. We'll scroll down to the cache setting. I'm going to set this end frame to 300. We're going to change the type over to modular and turn on is resumable. With that done, we can scroll back up to the top. We're going to change the resolution divisions to 96 and also the time scale. This is going to slow down the simulation. Let's go with a value of 0.65. And then finally, the one thing I forgot to do is over in the outflow section, make sure isPlanar is enabled, since this is also a plane object. Bring up the sample substeps to a value of 7 just to make sure no fluid actually leaves the outflow. Then we should be able to bake this in. Select your domain object, Control S to save, and then click on Bake. Now while this is baking, let me take a moment and let you know that if you want to learn more about Mantaflow or how it works in Blender, you can check out my classes on both the fluid and fire simulations over on Skillshare. In these classes, we go into depth on all of the settings and learn exactly how they work and how to use them efficiently. There's also a couple of hands-on projects where I walk you through how to create some unique and satisfying animations. If you are interested, you can check them out and my other classes for free because Skillshare is sponsoring this video. If you don't know what Skillshare is by now, it's an online learning platform where you can learn whatever you want, including Blender. They've got classes on animation, modeling, sculpting, architecture, and whatever topic that you can think of. So if you're wanting to learn more about the fluid or fire simulations or one of the thousands of classes that Skillshare provides, all you have to do is click the link in the description. The first 1,000 people to use this link will get 1 month free trial of Skillshare. I've been using Skillshare for over 3 years now and I can definitely recommend it. So go ahead, click the link in the description and start learning something new today. Thanks again to Skillshare for sponsoring this video. Now let's get back into the tutorial. The simulation has finished baking and here's the result. I'll go ahead and skip through the timeline and you can see it does look pretty cool. What we need to do is add in a new object. Let's add in a icosphere just like this. We'll set the subdivisions down to a value of 1 and then drag it over to the left and scale it down. Select your domain object and then head over to the particle system tab and you should see one called liquid. Go ahead and select it. We'll open up both of these panels. Let's set the amount down here in the viewport display down to a value of 35% so it doesn't lag our scene so much. Now we should be able to move around without it lagging. Next up, we're going to switch it from render as halo to render as object. And then for the instant object, select the icosphere. At the moment, the size is a bit too big, so let's bring the scale down to a value of 0.02. We'll try that for now. And that looks pretty good. I think we can go even smaller than that. Let's go 0.01. And the amount is still lagging our scene quite a bit, so I'm going to bring this down to only 10%. Now for the material for this particle. We're going to right click down here until you have a double arrow and select vertical split. Place it right in the middle and that will create 2 different windows. We're going to switch it over to the shader editor. Before we start working on the material, make sure you turn off show emitter in the render and show emitter in the viewport so we can actually see what we're working with. Then let's hide the rest of the objects. Let's hide both of these objects, the collision and the outflow, so I'll press H to hide them, so we just have the particles. Then select your icosphere and give it a new material. Let's press Z and go into rendered view so we can see what we're doing. For this material, we're going to be adding in a particle info node. So press Shift A, go over to input, and then add in a particle info node. This node only works in the Cycles render engine, unfortunately, so you're going to have to come over to the render tab and switch the render engine over to Cycles. In the particle info node, we have a thing called velocity. This means that we can take this output and plug it into different colors. We can control what the colors are based on the speed of the particles. So what I'll do is I'll press Shift A, add in a converter and color ramp. We're going to take the velocity, plug it into the color ramp, and then we're going to take the color and plug that into the base color. Let's go ahead and skip to a frame where there's a lot of movement. So probably like around here or so. And we can see here where there is not a lot of movement, it's going to have the black color, and where there is a lot of movement, like up here, it's going to have the white color. So if I select the white color, I can switch it over to a nice blue, something like this. And then where there's not a lot of movement, let's select the black and switch it over to a nice dark blue color, something like this. To brighten up our scene a little bit, I'll press Shift A, add in a color and then a hue saturation, and we'll place it right here. And then we're going to change the value of this up to 15. This will brighten out the scene quite a bit. Also in the color ramp, if we drag the handle closer, we should get a little more of the dark particles coming in. The other thing that we're going to do is when it's moving really fast, we're going to give it an emission value. To do this, we'll press Shift A, add in a new color ramp. We'll place it right here. And then we're going to leave both of the handles on white and black, but we're going to give the same position of this dark handle to the one down here. So underneath this position, I'm going to Control C to copy, select the black handle, and then paste that in the position down here so they're in the exact same spot. Then I'll take the velocity, plug that into the factor of the color ramp, and then this color is going to go into the emission strength right here in the principled shader. To control this a bit more, we're going to add in a math node, place it right here, and set this over to multiply. This bottom value now controls the strength of the emission. So if we go up to a value of 50, then we also need to change the emission color from black over to something else, and we'll just use the same color as the color ramp. So plug that in right there, and then we should see it come in, and as you can see, that is looking pretty good. So you can see here, if I skip to a better frame, there is more particles that are showing up, and if I skip to, let's say like a 13 or so, that's when the turbulence is very high, we can see this is the effect, and we get a lot of particles that are coming into the scene. If you want more of the lighter particles to come in, you can go over to the bottom color ramp and drag this value a little bit closer to the left. Let's actually go with a value of 0.05, so more of those particles show up. And then this one right here, I will also set that to that same value, 0.05. Now that the particles are done, let's go back over to the Particle System tab. We will select the domain object, and we need to make sure the viewport display is back up at 100%. With it set to 10%, this is also going to show up as only 10% in the render as well. So what I'll do is I'll turn it off in the viewport, and then I'll set the amount back up to 100%. And then I'll close off this panel. Let's add in a new plane to be the ground, and we'll scale it up pretty big. And then let's select the outflow, which I think is sphere 002. So we will enable it and then select it and just make sure, yep, it is the outflow. This is going to be the glass object that the particles are inside of. So jumping over to the material tab, we'll give it a new material. And for this material, we're going to set the transmission all the way up to a value of 1. And then the roughness down here, we're going to go down to a value of 0. If I press Z and go into rendered view, you're going to see this weird effect with the glass. The reason that's happening is because this object is completely thin. So let's jump over to the modifier tab, click add modifier, and select solidify. Then that should fix the issue. And as you can see, the glass is now working properly. As for the material, we'll give it a lighter white color. And then what we can do is set up the ground floor. For this, I'll just use a wood texture. If you want to use the same one I'm using, the link is in the description. And an easy way to add in all the textures automatically, I'll go back over to the shader editor, is if you have the Node Wrangler add-on enabled, you can select the principled shader, hold Control, Shift, and then T. This will bring up an open menu, and then you can navigate to the texture. Once you have found the texture that you want, you can select the color, the normal map, and the roughness. I'm not going to use the displacement, and then import the principled shader, and it will automatically plug everything in for us. Over here on the right side, I'm going to set the scale up to a value of 5, so we get smaller grains of wood, and I think that is looking pretty cool. As for the lighting, I'll select the lamp, bring up the radius, something like this, so it's a softer shadow, but you might get this annoying reflection in the glass. And an easy way to get rid of those is to select the lamp, go over to the object properties, and then underneath the visibility tab, you can turn off both the glossy and the transmission. And that's going to get rid of those white spots. And as you can see, that looks a lot better. I'm also going to bring up the strength of this. Let's go with a value of 2000. Then at this point, we can just set up the camera settings. I added a little bit of depth of field, and then in the render settings, I set the look to high contrast. Then make sure you also turn off both the collision and the flow object over here in the outliner so they don't show up in the render. The other thing I did was I scaled down the outflow so it's a little bit closer to the particles, and then I changed up a couple of settings in the compositor, like adding a vignette to darken the edges. You can also add in a little bit of glare if you wanted to give the particles a bit of glow. Play around with the settings until you're happy and then render it out. But there you go, that is it for this tutorial. Thank you very much for watching. If you created something cool from this project, I would love to see it, so make sure to send it to me on Instagram at BlenderMadeEasy. If you're new here, consider liking and subscribing for more Blender tutorials in the future. Thanks again to Skillshare for sponsoring this video, and I will see you in the next one.